This is notes for section 6.3, confidence intervals for population proportions. All right, so the whole chapter, we're continuing this idea that we have this value and want to find the lowest number that will work within some confidence interval and the highest number that will work within some confidence interval. So at the same train of thought, we're going to continue this idea with population proportions. Point estimate for a population proportion. Recall from section 4.2 that the probability of success of a single trial of a binomial experiment is p. This probability is a population proportion. In this section, you will learn how to estimate a population proportion, p, using a confidence interval. As with confidence intervals for mu, the population average, you will start with a point estimate. Definition of a point estimate. The point estimate for p, the population proportion of successes, is given by the proportion of successes in a sample and denoted by p hat is equal to x over n, where x is the number of successes in the sample and n is the sample size. The point estimate for the population proportion of failures, so the complement, is q hat is equal to 1 minus p hat. The symbols p hat and q hat are read as p hat and q hat. I know those are different types of figures, so make sure you know what they're called. Example 1. In a survey of 1,550 US adults, 1,054 said that they use the social media website Facebook. Find a point estimate for the population proportion of US adults who use Facebook. Okay, so our formula is p hat is equal to x over n. So our successes of our trial are 1,054 and our total sample size is 1,550. And if we use our calculator, we get that this is 0.68. This is our population proportion. Confidence intervals for a population proportion. Construct a confidence interval for a population proportion P is similar to constructing a confidence interval for a population mean. You start with a point estimate and calculate a margin of error. Definition of error and C confidence interval for a population proportion P. A C confidence interval for a population proportion P is P hat minus E to find the lower and P hat plus E to find the upper. And that E, that error, is found by E is equal to ZZ times the square root of P hat times Q hat over N. Now this ZZ value comes back from section 6.1, which is the critical value attached to the certain percent, that confidence interval. So recall from section 6.1, we had a chart that told us that if we work with 90% confidence, then our critical value, our ZC, was 1.645. 95%, we had a critical value of 1.96. And 99% confidence, we had a critical value of 2.575. And don't be thrown off, Q hat, remember, is P hat minus 1. I'm sorry, 1 minus P hat. 1 minus P hat. So here are your guidelines, here are your steps. You first want to identify your N and your X. 2, use your formula for P hat, X over N. 3, we have to make sure that it's approximately normal. That's if it's not stated. So we want to make sure that this inequality holds true. N times P has to be more or equal to 5, and 1 times 1 minus p hat is greater or equal to 5. 4, find the critical value ZC that corresponds to the given confidence level of confidence C. 5, find the margin of error, and that's your formula. Again, don't forget that Q hat is 1 minus P hat. And 6, we're going to add and subtract that E to our P hat to find that interval. So again, I like to draw it. It makes more sense. So we're going to subtract that value E, and we get our minimum value, our lower bound, and we're going to add that value we find E, and that will give us our max. Okay, let's go ahead and do example 2. Now for example 2, we're going to do it by hand, and then we're going to do it again using our calculator. All right, so I'll save some space for our calculator work. All right, let's go through our steps. Now we have our steps listed above, right? We have our first step, step 1, identify n and x. Okay, step 1, for example, it reads, use the data in example 1 to construct a 95% confidence interval for the population proportion of US adults who use the Facebook. All right, so we said that X is our sample, so, our sample, so we have 1054, and N is our total sample size. Step 2, we have to write the proportion, right? So P hat is equal to X over N. So we have 1054 over 1550, and we calculated from example 1 that that was 0.68. All right. And we continue with step 3. Step 3 reads, we verify that's approximately normal. All right, it doesn't tell us approximately normal, so we have to make sure it is. So it gives us two formulas. One of them is n times p hat, and you have to make sure it's bigger or equal to 5. All right, so let's fill in that formula. If we do, n, we have n right here. N is 1550, so 1550 times P. P is 0.68, and we want to make sure we don't know if it's more than 5. Okay, we work this out using our calculator. We punch that in, we get 1054. All right, that's more than 5, so that checks out. And there's a second formula I have to check out, and that's n times the complement, so 1 minus p hat. I need to make sure that it's more than 5. All right, so n is 1550, and we have 1 minus 0.68. We want to make sure we don't know that it's more than 5 or equal to 5. All right, so 1 minus 0.68, that gives us 0.32. And we're going to multiply that by 1500. All right, we multiply those two together, and we get 542.5. And all that matters is that it's more than 5 or equal to 5, and it does. So we can say it's approximately normal, our distribution. All right, step 4. Step 4 above reads to find that critical value, that ZC. So we're working with a confidence interval of 95%. So therefore, that tells us that we have a ZC of 1.96. And we use that from our chart from section 6.1. And I also quickly referenced that chart in the beginning in the first page. Step 5, find our error. Okay, for step 5, we have an error formula, and it's E is equal to ZC times the square root of P hat times Q hat all over N. All right, let's go ahead and substitute those values. We found that ZC is 1.96. P hat is 0.68. Q hat, well, we found Q hat right here, right? 1 minus P hat, and that gave us 1 minus 68, it gave us 32. So we're going to multiply by 0.32. All over our N, and our N is 1,550. All right, we work this out in our calculator, and we get that it's about 0.0232. All right, that's our error, our E. All right, so we have some p-value. Our p-value is 0.68. And I'm going to add and subtract that E. So if I subtract 0.0232, so let's do that word, 0.68 minus 0.0232. We use our calculator, and we get something that's close to 0.6568. All right, we take that same P and we're going to add that E. So our P is 0.68 plus 0.0232. We get about 0.7032. And those two make up our answers. So our answer is between 0.6568 and 0.7032. Now the work isn't so bad, but it is lengthy. Luckily, we have our calculator to guide us through this process. All right, so for our calculator, we're going to start off by opening up our calculator, turning it on, and we go to Stat and press the Stat button. Scroll over till you see Test, the third option, and then you want to scroll down. You want to scroll down until you see 1, prop, proportion, Z-int for Z interval. For me, it was option A, so I had to scroll a bit. From there, you're going to enter 3 pieces of information. You're going to enter your X, your N, and your confidence interval, your C level, and it'll give you an answer. So for us, we had an X, we have it listed above, right? We have an X of 1,054. We have an N of 1,550, and we have a confidence interval of 0.95. So once we enter those pieces of information, it gives us an answer as a confidence interval. So it gives us 0.65, 678 to 0.70322. And it also lists, gives us what our p hat is and what our n is. Now, if you'd like to see a calculator, you can watch this video and it shows you how to punch into your calculator using the same steps listed above. All right, so this is confidence intervals with proportion. Again, we're dealing with the same ideas as we did before. Section 6.1 dealt with standard deviation, particularly population standard deviation. 6.2, we worked with a sample standard deviation, and it was a bit different. Now here for 6.3, we're working with proportions. But again, it's the same idea, confidence intervals. What's different is what you're given for each problem. All right, if you have any questions, please feel free to email me or post your question in our discussion board. Thanks.